Hi everyone, welcome to the live session of week 3. So I will wait for 10 to 15 minutes and then uh, I shall start. Okay, for people to join. Okay, I think we should start now. Okay, so the topics that were covered in week 3 were the one-sided limits, limits at infinity, infinite limits, and so on. All right. So my task during this live session is mainly to help you with the assignments, to solve the assignments or any other doubts possibly if you have. So I usually keep in mind the assignment questions and then uh, make the questions for the live session so that it is beneficial for you guys to, if you not attend, to at least see the recording afterwards. Okay, so uh, we shall do some questions. So topics covered were one-sided limits, limits at infinity, and infinite limits. So if you haven't watched the lectures first, you should watch that probably first and then come back to see the live interaction session later on. So question number 1, you have to evaluate the limit x tending to 0, x square minus 6x plus 9 upon x cube minus 4x square plus 3x. Now we have to find the limit of this function at x equals to 0, so that the denominator is becoming infinity at x equals to 0 and numerator is some finite value at x equals to 0. Had it been a 0 by 0 form or an infinity by infinity form, we would have tried to eliminate uh, uh, this x in the numerator and denominator, but it will not happen here. Also, you can see this by factorizing. So if you factorize, this becomes x square minus 6x plus 9 upon, so this will become, you take out x common, x cube minus 4x plus 3, which is x square minus 6x plus 9, that is as it is. This is x minus 1. You can factorize it into x minus 3, x square minus, yeah. So and this, and even the numerator, so you can see that x minus 3 is the common root. So if you had to find the limit x tending to 3, that would have been finite, because that is eliminated from the numerator, so from the denominator. So this is, yeah. Now we'll have to, now we know that limit will be infinity or minus infinity, because x tending to 0, this is 3, this is 1, and this will make it infinity. It is like 1 by x. But you will have to see the left hand limit and right hand limit. Left hand limit is limit x tending to 0 plus x minus 3 upon x minus 1. So x minus to 0 plus means we approach 0 from the right hand side. So this is, so this numerator will be, when x is a little greater than 0, so numerator will be negative upon this, x will be positive, and this again, x is greater than 0 but still less than 1, so this will give you negative. So this overall will become positive, so it will go to plus infinity, right? But if you see that if x tends to 0 minus x minus 3, x minus 1, x, so again numerator, it means we approach 0 from the left hand side. So numerator will again be negative, but this will be negative now, negative, so overall it will be negative, so it goes to minus infinity. So this is how you can take an idea of if the limit will be plus infinity or minus infinity. So right hand limit is not equal to left hand limit. So it had some options. A option was is a real number, B was is minus infinity, C was is infinity, D was does not exist. So from left hand and right hand we are getting two different values, implies the limit does not exist at 0. So D option is correct. So D option is correct. Okay. Question number 2. So we'll do more or less questions on the similar lines only today. Okay. So limit, have to find the limit at infinity of cos square x plus 2 upon x equals. So A part is minus infinity, B part is 0, C part is infinity, and D part is a non-zero real number. Okay, so whenever there are some trigonometric type of things, you can try to see that the trigonometric function will be bounded, and if the limit of the other function exists and is 0, then the overall limit will be 0. So you can see that mod of cos square x plus, so cos square x will be less than 1, implies cos square x plus 2 will be always less than 3. Right? So this function is a bounded function. And this is positive, so you can in fact write mod of cos square x plus c is less than 3. So, and you know that limit x tending to infinity 1 by x is 0. Okay, this has been discussed in lecture class also. Implies limit x tending to infinity cos square x plus 2 by x is 0. This will always be positive, and this 1 by x when x goes to infinity will make the whole limit to be 0 because the other function is bounded. Had the other function also been giving some infinite value or a 0 value, we could not have then said that, right? If it would have given some numerator would have been 0, then also we could have said the limit is 0, but essentially here the function is bounded, so, and limit extend to infinity 1 by x gives you 0, so the overall limit is 0. All right. Question number 3. Limit extending to infinity sine square x square. So here the correct option will be B. You have to find is has the limit A is minus infinity, C is 0, sorry, B is 0, C is infinity, and D a non-zero real number. Okay, so firstly see this is the question has not said anything, but I am assuming this is a greatest integer function, or you say that the floor function. So how will it take values? Since it is what do you say? It is root x, so it will x has to be, it will take positive values only. So it will be 0 when 0 less than root x less than 1. It will be 1 when 1 less than root x less than 2, right? 2 when 2 less than root x less than 3, and so on up to. So in terms of x, it will be 0 when 0 less than x not 1 here, less than 1, 1 when 1 less than x less than 4, right? And 2, 2 less than x less than, sorry, 4 less than x. And so also note here that x is positive. That's why when it was root x less than 1, so I'm squaring the whole equation. So the inequality is not changing because x is positive. Because the function of y equals to x square when x is positive is increasing, meaning that when x is increasing, the value of y also increases. So it implies that if x, say a is greater than b and a comma b are greater than 0, then a square is greater than b square, right? Because if a is here, b is here, then a square is here and b square is here. But if you take the opposite side, if a and b are less than 0, so say here is minus a, here is minus b. So minus b is less than minus a, but minus b square will be greater than minus a square. So that's why squaring here, because x is always positive, is not making any difference in the inequality, but you cannot every time blindly do that. You have to take care about all of these things. Alright, so this is basically the function, the greatest integer of root x. Greatest integer just means that the greatest integer which is less than the value we are evaluating the function at. So if we are evaluating the function at 0.5, so the greatest integer which is less than 0.5 is 0, right? Okay, so you can see that so 0 to 1, this is 1, then 1 to 4, this is 0, then please ignore the scaling here. 2, so 1 to 4 to 9, it is 2, right? So as x tending to infinity, you can clearly see that greatest integer is also tending to infinity. So implies limit x tending to infinity, greatest integer function goes to infinity, implies limit x tending to infinity 1 by greatest integer function will go to 0. Now again, as in above question, sine square x square will always be bounded by 1. So this and limit x tending to infinity 1 by 0. So this implies the overall limit will be nothing but x sine squares x square. Please, I'm sorry for my handwriting, is 0, right? So these were two questions to tell you that one of the function is bounded and the limit of other uh, at limit of the denominator you can say is infinity, or 1 by the denominator is 0 at the point where you have to validate the limit, then the overall function has the limit to be 0, right? All right, question number 4. So in question number 4 to 7, you have to adopt a notation that limit x tending to 0 minus fx, that is the left hand limit of fx at 0 is a 0 minus, and limit x tending to 0 plus fx is b belongs to real number, belongs to real number. Now you have to find, another question is limit x tending to 0 plus f of x4 minus x is a 0 B, the number A, which is the left-hand limit of fx at 0. C, right-hand limit of fx is 0, and D, none of 0, A and B. Now, how to solve such questions? So you know the limit of fx at 0, right? You have to evaluate uh, the limit of f. The argument has changed from x to x4 minus x. Now, I would like to just mention here, you have not studied continuity of a function, but had the function been continuous, you could have simply taken the limit inside of the function. Had the function been continuous at 0, then you could have taken the limit inside of the this f, meaning that you could have written limit x tending to 0. This is equal to limit f limit x tending to 0 x4 minus x, right? So the value is at whatever the value is at f0, because this limit is 0. But here there's no information about f, so you cannot simply do that, right? And moreover, you have to evaluate the limit in terms of a, b, or 0, and you have not been given the value of f0. Alright, and even the function had been continuous at 0, then this left hand and right hand limit would have been equal, and would have been equal to the value of the function at 0. But none of this is happening here, so we'll have to find some other way. So you just take y equals x4 minus x. Alright, so now you have to evaluate the limit at 0 plus. So now when x tending to 0 plus means x is a little greater than 0, but still less than 1. Not very much larger than 0, because whenever we see the limit, we evaluate it, we see the behavior of the function at that point locally, right? That how is it behaving near 0, because we have to find the limit at the point 0 here, so I'm saying 0. So how is it behaving near 0? We cannot go very far to 0. The behavior might change. So we may assume when x is 0, we may assume that x is between 0 less than x less than 1. Why we are doing this? Because x4 and x will have a different relation when x is between 1 and when x is less than 1, when x is greater than 0, x is greater than 1. So when x is tending to 0 plus, we are trying to say where y will go, and that depends upon how x4 minus x x4 and x are related. So that's why we have to see whether x is less than 1 or x is greater than 1. Okay, so if this is the case, then since x is less than 1, so x4 has to be less than x. This is the standard basic calculus thing, that when x is less than 1, the value, the more the power, it will come down, right? So x4 less than x and x is less than 1 implies x4 minus x is less than 0, implies when x tends to 0 plus, y goes to 0 minus. Okay, so limit of x tending to 0 plus f x4 minus x is equal to limit of y tending to 0 minus f of y. And we know this value, this is simply a variable, you can write it x, y, z, anything you feel like. So you have been given this value to be a. So this is equal to a. So our correct option is B. Okay, so this is how you solve such questions. Question number 5. Again, we have to follow the same terminology, that x going to 0, fx is a, x going to 0 minus fx is a, 0 plus fx is b. Okay, so keeping that in mind, you have the next question. Limit x tending to 0 minus this time of x. So I shall not do this x f x4 minus x, right? Okay, you have to evaluate this, and again the same options is a 0, b a, c b, d none of 0 a and b. So solution, again let y equals x4 minus x, and we have to value the limit x tending to 0 minus, so again a little less than 0, we may assume minus 1 less than x less than 0. Now you can see that minus 1, if x less than 0, then x4 is positive, but x4 will be less than 1. Why is that? Because x is positive and x is less than 1. So see, when x is less than 1, less than minus 1, but x is, sorry, x is, I've written it. So when x is less than 0 and x is greater than minus. So when x is less than 0, I have already told you the graph of the function y is equal to x square is decreasing, meaning that when this is minus 1 and x is somewhere here, so when I square this, so the value of x square will be less than the value of minus 1 ka square. So implies x square will be less than minus 1 ka square, implies x square is less than 1. And now again, if you square, since x square is positive, you are square. Now this is your a, this is your b. When you square both of the sides and both of them are positive, then what do you say? The graph of the function here is increasing, meaning that if a is greater than b, then a square is greater than b. Sorry, I've said it opposite, that if a is less than b, then a square is less than b square. So now x4 is less than 1. So that's why you have this inequality. So this will imply x minus x4 is less than 0, right? Implies x4 minus x is positive. So when x goes to 0 minus, we will have that y goes to 0 plus. Alright, so limit, so we have to evaluate the limit of this x going to 0 minus x f of x4 minus x. Now using algebra of limits, since the limit of both this function x and f of x4 minus x exists, so we can separate them. So limit x tending to 0 minus x into limit x tending to 0 minus fx4 minus x, this is equal to 0, right? Left hand and right hand limit, this is finite, so it is the same value. It is equal to the value of the function of 0. So this is 0 and this is, though it would be 0, but I just need to tell you that this is a finite limit. That's why if I multiply with it with 0, then it will come out to be 0. So this is 0 plus f of y. So this is 0 into, we have this b equals 0. So our correct option is A. Alright. Okay. Question number 6. You have to evaluate limit x tending to 0 plus fx5 minus fx4 minus x cubed minus x square is again the same option 0, a, b, none of 0, a comma b. So I'm waiting for 2-3 minutes. Please try it yourself. Okay, I hope you have tried it. Alright, I don't think it is difficult, so I guess you should be able to do this. So just factorize, right? So this can be written as x cube minus x and x square minus x. Okay, just it is easy to factorize. Please do this. Just take out this x cube common, x cube common from here. You will be left with you take out x square common from here, x cube and x, and then again it will be x square and x and factorize. So when limit, so we have to value the limit at x tends to 0 plus again. So just see if so for limit is x tends to 0 plus, we can assume 0 less than x less than 1. Then how will the function behave? 0 less than x cube minus x square less than, because x is positive, so and less than 1, so you just have to take care that this as the power increases the value will decrease. So x cube minus x less than 0 and x square minus x less than 0, so implies y equals to x cube minus x square minus x is positive, so as x goes to 0 plus implies y goes to 0 plus. So the limit of x tending to 0 plus fx5 minus fx4 minus x cube plus x square is equal to limit y tending to 0 plus f of y. This is nothing but b. So our correct option here is C. Okay. Question number 7th. So limit x tending to 0 minus f of x5 minus x4 minus x cube plus x square is again you have the same function but different limit, uh, 0 minus left hand limit. Okay, so again when you evaluate factorize x5, it is the same, so you just have to see that x square common, x cube minus x minus x common, you will have x square minus x, so it will be x cube minus x, x square minus x, sorry, x square here. All right, I think I've done something incorrectly. So if you take Yeah, sorry, x cube common. I think it was correct. x5 have I done the factorization wrong here? x5 minus x4 minus x cube. No, it's correct. So I just have to take x common here. So x, when I take common, so it will be x square minus x, yeah, x cube minus x square minus x, right? So this is this. So when now x is between, so when we have to see the limit as x tending to 0 minus, we can assume minus 1 less than x less than 0, right? So now you have to see what is the relation between x cube, x and x square and x. So minus 1 x, now see, x cube is positive. Sorry, x cube is increasing, means the value of the graph function is somewhat like this, that whenever uh, the function is increasing, the value of the graph is function is increasing. Well, whenever the argument is increasing, the value of the function is also increasing. So x will be less than, again, x cube, and x cube will be less than 0 when x is less than 0, right? And x square will be positive, but x square will be less than 1 because x is greater than minus 1. Again, when you square it, since x is less than 0, x square will become less than 1 because the function of graph of the function x square for x less than 0 is decreasing like this, right? So this is what you will get as your um, relation between x cube, x square and x. So what do we have here? That x cube minus x is positive and x square minus x is positive, right? So again, so y equals to x cube minus x and x square minus x is positive. So as x tending to 0 minus implies y goes to 0 plus implies limit x tending to 0 minus f of x5 minus x4 minus x cube plus x square is limit y tending to 0 plus f of y, which is again B. So our correct option is C. Okay, I hope it is clear now how to you have to solve such questions. All right. Now the next type set of questions here is based upon the limit that limit x tend to 0 sin x by x is 1. Okay, so this you can it has been very elaborately discussed in the lecture, so you can simply see that, or you can also see that by the sandwich theorem, that sin x is less than x, uh, like that. Okay, I'm not going into the details of that because it has already been very widely discussed in the class. So limit, you have to find tan of 1 minus secant x upon x is, just don't get intimidating by seeing such questions. You just have to play around with the trigonometric functions. All right. So first of all, just whenever there is an argument which is not x and some thing other than x, then try to put. So see, firstly, just because what we are trying to do is we are trying to write tan x as sin x by cos x, and if I do x sin x by cos x, and then you know separate the limits, x tend to 0, limit x tending to 0, sin x by x, limit x tend to 0, 1 by cos x. So this is 0, this is 1, this is 1. So all of them are finite. So that's what I'm trying to make here. So we'll have tan x, just multiplying and dividing by the argument, 1 minus secant x, okay, 1 minus secant x upon x. So we'll try to see if these two have finite limits, then we'll separate them and evaluate the limit by multiplying the limits of the separated functions. So firstly, if you see limit x tending to 0 secant x upon 1 minus secant x, okay. So t equals to 1 minus secant x equals 1 minus 1 by cos x. So when x tending to 0 implies t tends to 0. Cos x is 1, so 1 minus 1 will 0. So this limit is limit t, you can say this limit t tends to 0, tan of t upon t. So this is limit t tending to 0, sin t upon t into cos t. Now you can separate this limit t tending to 0, sin t upon t, and limit t tending to 0, 1 upon cos t. So this is 1 into 1, so this is 1. Now limit x tending to 0, 1 minus secant x, just give me a minute, I'm sorry. Okay, I'm sorry. So this is this. So firstly see that 1 minus secant x is 1 minus 1 by cos x. We're just trying to, evaluate everything in terms of sign, because we have this x lying around here in the denominator. So we want to use this limit, right? So this is cos x minus 1 upon cos x, and half formula identities, half angle identities. This is 2 sine square x by 2 by cos x. So this is equal to, so just so limit x tending to 0, 1 minus secant x by x is limit x tending to 0 minus 2 sine x square by 2 upon cos x into x, right? Now what you can do, you can merge one x with this x. So this becomes, so this limit is limit x tending to 0 minus 2 sine x by 2. Just okay, you can take x in the, okay, so this is the limit, this, okay, you can, because if you take x by 2 equals to y, x goes to 0, x by 2 goes to 0. So is there any problem with my, right? And minus can come out, and this is 1 sine x by 2 is remaining, 1 x by 2, and limit x into 0, 1 by cos x. So this will be 1 into 0 into, so this is basically minus 1 into 0 into 1, which will give to be 0. So our final limit, limit x tending to 0 tan 1 minus secant x upon x is limit x tending to 0 tan 1 minus secant x upon 1 minus secant x into limit x tending to 0 1 minus secant x upon x. We have separated them because we have found both of the limits to be finite. So this one was 1 and there was 0, so this is 0, right? So the correct option is A. All right, I've done some, this is 8th. Yeah, question number 9th. Limit x tending to 0 sine of x cube minus x upon x. Again, we have to use that limit x tending to 0 sine x upon x. So this is limit x tending to 0 sine of x cube minus x upon x cube minus x. So again, x tending to 0, x cube minus x will go to 0. So, and I'll not separate them first. So x cube minus x upon x. So firstly see that limit x tending to 0, x cube minus x upon x is limit x tending to 0, x square minus 1 upon x. This got cancelled, so this is minus 1, right? And limit x tending to 0 sine of x cube minus x upon x cube minus x. If you put t equals x cube minus x, so x goes to 2 implies t goes to 0. So this limit is equal to limit t tending to 0 sine t upon t, which is 1. So finally, limit x tending to 0 sine of x cube minus x upon x is limit x tending to 0 sine of x cube minus x upon x cube minus x into limit x tending to 0. Because both of them are finite, we have separated them upon x, and this was coming out to be 1 and this was coming out to be minus 1, so the limit is minus 1. All right, so our correct option is, okay, so I have not written down the options here. So it was A 0, B minus infinity, C infinity, and D a non-zero real number. Okay, so correct option is D. Okay, so I hope you'll be able to do such type of questions now. So next question is based on evaluating the right hand and left hand limit. So The first question in this regard is evaluate limit x tending to 1 fx, where fx is defined as x minus 1 minus mod of x minus 1 upon x minus 1 and x is not equal to 1, and 1 when x is equal to 1. So whenever there is a mod, you just try to firstly break the function, how function is looking like. So this function will look like fx x minus 1 minus of x minus 1 upon x minus 1 when x minus 1 is greater than or equal to 0, that is x greater than or equal to 1. Then x minus 1, because mod of x minus 1 will open in x minus 1 when x minus 1 is positive, and minus of minus x minus 1, which is plus of x minus 1 when x minus 1 is less than 0, is x minus 1. So this is when x minus 1 is less than 0, that is x less than 1, and 1 pet is, anyway we don't care much about what is the value of the function at 1 when you are evaluate the limit at 1, but anyway at least the function is defined at 1, so we'll write it. So this will become x cancel minus 1, so this is 0 when x is greater than or equal to 1. Sorry, here x is defined separately for 1, so we'll not include greater than or equal to here, greater than, right? So greater than 1, and x less than 1, this is coming out to be will be 2x minus 1 upon x minus 1, so this will be 2 when x is less than 1 and 1 when x is equal to 1. Now see that limit x tending to 1 minus when x is less than 1, fx is approaching 2, and limit x tending to 1 plus fx is approaching 0, implies left hand limit is not equal to right hand limit, implies limit x tending to 1 fx does not exist, right? Okay, so this was one question on left hand and right hand limit, which was based on modulus function. And now a very common question upon right hand left hand limit is when it includes the exponential function. So firstly note that, so this will be question number 11. So evaluate gx, where gx is defined as x e1 by x minus e minus 1 by x e1 by x plus e minus 1 by x when x is not equal to 0, and 0 when x is 0. So firstly see that how the function e raised to power x is like, this is like this. So it goes to infinity as x goes to infinity. Alright. So e raised to power minus x is 1 by e raised to power x will go to 0 as x goes to infinity. Keep this in mind and we'll evaluate this function. Okay, so now this is the function. We'll evaluate the left hand and right hand limit. So right hand limit, firstly the limit x tending to 0 plus x e1 minus x minus x e minus 1 by x upon plus e1 by x. So we convert it into 0 plus h type of thing. So x go 0 plus h and h tending to 0. We get 0 plus h e raised to power 1 by h minus, so this is x and this is 1 by h e raised to power 1 by h plus e raised to power 1 by h. So this is limit h tending to 0 e. So I'll just take e raised to power 1 by h common. This is 1 minus e raised to power minus 2 by h upon 1 plus e raised to power 2 by h. Sorry, this is minus, right? Yeah. Okay. So this gets cancelled. So this is limit h tending to 0 h 1 minus e raised to power minus 2 by h upon 1 plus e raised to power minus 2 by h. So when h tending to 0 implies 2 by h goes to infinity. So e raised to power minus 2 by h is 1 by e raised to power 2 by h, which goes to 1 by infinity equals 0. So this limit is limit h tending to 0, h tending to 0 is 0. Again, I have separated the limit h tending to 0 0, and limit h tending to, I should write it like this, 1 minus 2 by h upon 1 plus e minus 2 by h. Using algebra of limits, this will be 1 minus 0 upon 1 plus 0, and this is 0. So this becomes 0 into 1, which is 0. So our right hand limit is 0. Now left hand limit. So this will be like limit h tending to 0 f of 0 minus h. So this will be limit h tending to 0 minus h e raised to power minus 1 by h minus plus 1 by h upon e raised to power minus 1 by h plus e raised to power plus of 1 by h. Now again, limit h tending to 0 minus h as it is, taking out common e raised to power 1 by h. So we get e raised to power minus 2 by h minus 1. Again, e raised to power 1 by h common, e raised to power minus 2 by h minus 1. Again, we can separate the limit because both of them are finite. H tending to 0 minus h, limit h tending to 0, e raised to power minus 2 by h minus 1 upon e raised to power minus 2 by h minus 1. So this is again 0 into 0 minus 1 upon 0 minus 1. So this will be 1 equals 0. So implies left hand limit equals to right hand limit, implies limit x tending to 0, gx is 0. Right? Also, what is this technique? I think Sir has already discussed that when x is going to 0 plus, we are just writing x to be some 0 plus में h, where h is positive, and this essentially is h tend to 0 plus. Okay? Or you simply, when there is no plus, we simply mean that x tend to 0 plus only. And here we write x equals to 0 minus h because we had to evaluate the limit when x goes to 0 from the left, matlab negative. So 0 se thoda kam, we have come, that quantity which is come is minus h, and h is positive, so h tends to 0 plus again here. Okay. Okay. So this is one way to evaluate the functions, the limit, left hand limit and right hand limit. Okay. Now question number, again one more question on left hand and right hand limit. So fx is limit, just note the function here carefully, that f at each point x is defined as a limit of another variable n tending to infinity, e raised to power x minus x raised to power n sin x upon 1 plus x raised to power n, when x is between 0 to pi by 2. So evaluate limit x tending to 1 fx. So why 1 is a problem here? Because when n tend to infinity, x raised to power n can go to infinite limit or to 0 depending upon the how x is behaving. So for x greater than 1, limit n tending to infinity xn is infinity. Matlab x square x cube when you do, and x is greater than 1, so the value of the function will increase. But If x is less than 1, and if you increase the power, then x raised to power n decreases, right? Okay, so now fx is, firstly we'll try to see what fx is without the term, without the variable n. If we can evaluate this, then well and good, we'll have fx in terms of x only. So we are trying to eliminate this n thing here. So how we can do that? And just adding and subtracting sine x. Okay, so this is limit n tending to infinity e raised to power x by sine x upon 1 plus xn minus sine x 1 plus xn upon 1 plus xn. So this get cancelled. So this is limit n tending to infinity e raised to power x plus sine x upon 1 plus xn minus sine x. Now we'll see how, what is the value of the function for less than 1 greater than. So firstly for f1 it is limit n tending to infinity e raised to power, what is this, 1 minus x raised to power 1 will be sine x upon 1 plus 1. So this is e minus sine x upon 2. Okay. So now when x is less than 1, also this n tending to infinity, x is fixed here. So this will be ex plus sine x upon 1 plus limit n tending to infinity x raised to power n minus sine x. Now we'll have to see what is the value of x raised to power 1, x raised to power n depending upon x is greater than 1 or less than 1. If x is less than 1, limit n tending to infinity x raised to power n is, what is it? 0. So implies e raised to power x. So fx will be, fx is e raised to power x plus sine x upon 1 minus sine x, which is e raised to power x. X greater than 1, limit n tending to infinity xn is infinity, implies 1 plus limit n tending to infinity xn is infinity, implies fx is, for fixed x this will become 0, 1 upon, or we can say that 1 upon 1 plus limit n tending to infinity xn is 0. So first term will vanish, so we'll be left with minus of sine x, and f of 1 we have already evaluated. This is coming out to be e minus sine, what is it, sine of 1 by 2, e minus sine of 1 by 2. So finally we have fx just in terms of x. This is, yeah, x लेस देन 1 के लिए e raised to power x, x लेस देन 1 के लिए e minus sin 1 by 2, x equal to 1 के लिए, और minus sin x for x greater than 1. Now the value, now we have to find the limit. So limit x tending to 1 minus fx, when x is less than 1 is limit x tending to 1 minus, so this is e raised to power 1, this is e, and limit extending to 1 plus fx is limit x tending to 1 plus. Now 1 minus does not affect here because e raised to power 1 is finite, so the value of the limit will be the functional value only. So e, again x into 1 minus 1 plus is sine x equals minus sine 1. Again it is finite, so simply put the value. So e is not equal to minus sine 1, implies left hand limit is not equal to right hand limit, implies limit x tend to 1 fx does not exist, right? Okay, so I hope this question was clear. Now we will do some more questions, some easier questions on left hand and right hand limit. So this is limit x tending to 1 plus root 2x this root of 2x x minus 1 upon x minus 1 and limit x tending to 1 minus root 2x x minus 1 upon mod of x minus 1. Okay. So when x is greater than 1, x minus 1 is positive, implies x minus 1 is equal to x minus 1. Mod of x minus 1 is x minus 1. So this limit is limit x tending to 1 plus root of 2x x minus 1 upon x minus 1. This gets cancelled. Limit x tending to 1 plus root 2x. When you put x equals to 1, it is finite, so the value will be simply under root 2. And here, when x is less than 1, x minus 1 is less than 0, implies x minus 1 is minus of x minus 1. So limit x tending to 1 minus root 2x x minus 1 is minus of x minus 1. So this is limit x tending to 1 minus root 2x and 1 negative. So this is simply put 1 here, so minus of under root 2. So again, we don't have right hand limit equals to left hand limit, right? So the limit does not exist at 2, but this was not the question here, just a general remark. So B is limit theta tending to 3 plus floor function theta upon theta and limit theta tending to 3 minus again the same floor function upon theta. Try to evaluate this. I'll wait for 1 to. Okay, so I think it's not difficult. So when theta is greater than 3, means theta lies somewhere here. So the greatest integer less than theta will be 3. So this will be, so floor function here will be 3. So limit theta tending to 3 plus, right? Or you can just write it like three upon theta. You can see, so limit 3, this is 3 upon 3. So this is 1. And here when theta is less than 3, so the greatest integer which is less than theta will be 2. So the floor function is 2, implies limit theta tending to 3 minus floor function ka value is 2 upon 3, which is 2 upon, will be 2 upon, you just have to put the value of the limit, value of the floor function, it is limit theta tending to 3 minus 2 upon theta, which is 2 upon 3. So again the limit does not exist at 3. Okay. One more question, limit t tending to 4 plus t minus, again floor function of t, limit t tending to 4 minus, again t minus floor function. So this will be, again, t when is positive, the floor function will be 4, and when we put 4, this is why 4 minus 4 equals 0, and when t less than 4, floor function will give you 3. So this will be 4 minus t is, when you put t tends to 4, t is 4, and this will be 3, which will be, again, the limit does not exist. Okay. All right. One question on, again, the sin x and cos x limit. I've lost count of questions by now, so this is question number 14. You have to evaluate limit x tending to 0, x plus x cos x upon x sin x cos x. So this is limit x tending to 0. I'm separating them because I can see x by sin x here. Again, x by sin is x by sin x here, x by sin x here. So I'm separating the terms in the numerator. X by cos x gets cancelled. X by sin x cos x, x by sin x. So this is 1 by sin x by x cos x plus 1 by sin x by x. Now you can just put the limit here. This will be 1 upon 1 into 1 plus 1 upon 1. So this will be 2, right? So one simple question again. Question number 15. The limit y tending to 0 sin 3y upon 4y. Now you cannot simply just say that this is 1, because here the argument is different, 3y and 4y. You have to, when you see the limit x tends to 0, sin x 1, x is 1, here it's x, here it's x. So you have to make that uniformity first and then use the limit. So how you can do, just simply multiply and divide by what you need. Sin 3y upon 3y into 3y upon 4y, right? So this is limit y tending to 0, this gets cancelled. This is an equal, this is 1, and this scalar can be taken out, 3 by 4 into 1. Okay, because here you can put theta equals to 3y, y tending to 0, theta tending to 0. This limit becomes limit theta tending to 0 sine theta upon theta, which is 1. Okay, this is question number 15. Now one question on infinite limits. So you have limit x tending to 2 plus 1 upon x square minus 4, limit x tending to 2 minus 1 upon x square minus 4. So this is 2 plus pi. There is a problem 2 pi because this is becoming infinity. So we have to say, see, it is minus infinity or plus infinity. 2 plus 1 upon x minus 2 and x plus 2. Again, limit x tending to 2 minus 1 upon x minus 2 and x plus 2. So when x is positive, x is greater than 2, this will be like positive, this will be positive. So this will become infinity when you put 2, right? And when x is less than 2, 1 upon, when x is a little less than 2, this will be something 1 point, and this will give you negative, but this is again 1.2 minus 1.2 will be negative, positive. So this is negative, so this is minus infinity, right? Also, there is a problem at minus 2, so exercise limit x tending to 2 minus 1 upon x square minus 4 and limit x tending to 2, sorry, not 2 minus, minus 2 minus and minus 2 plus. Let me write it clearly. You have to evaluate that. Alright. So I'll do just one more question on infinite limit. So question is limit x tending to 0 plus 1 upon x1 by 3 minus x minus 4 by 3 and limit x tending to 0 minus 1 upon x1 by 3 minus x minus 1 by 3. So now see that problem at 0 and 1, because it is becoming infinity, again we have to see that minus or plus. Again the same trick, x greater than 0, this will be positive, x greater than 0 something 0.1, this will be this will be positive, this will be 1, right? This will be something, this will give you 1 upon something 1 upon 1, and this will be positive, negative, and this is some less than 0. So sorry, this is some positive, the greater than 0, 0 point something, but 0 point something, say 1 minus 1 will be negative. So overall, sorry, I have done some mistake here. 0 plus this will be 0 plus this will be positive, right? And this will be 1. Extending to 1 upon 0 minus 1, 4 by 3, 1 raised to power. Okay, so this will be something less than yeah, so this will be something, so this will be 1, 0 minus 1, 4 by 3, this is something 1, 0 point something 1 minus 1, so this will be negative, so this is minus infinity. So now here this is something negative minus 0, and this is negative, so this is again minus infinity, right? I think this is right, fine. Yeah, I'm sorry. This is not, this will exactly not be 1 when x is greater than 0. So this will be something less than 1. So overall 1 upon this will be something greater than 1, right? And this is something 0 point greater than okay, there is again 1 upon, so this is less than 1, so this is 1 upon something greater than 1. Yeah, so greater than 1 will be 1 upon something 2, and this is again you can say, if you simply put 1 here, it will be something, yeah, 1 minus 1, this is positive, so this is infinite. Yeah, sorry, I got a little confused. So there's 1 upon, so when you put x positive, some 0.1, 1 upon this will be greater than 1 overall. So, and this will be some, when you put simply 0, it will be 1, so it will be positive. And here when you put something negative, if overall it will be negative, and this will also become negative because this is positive, so simply it will be minus infinity. Okay, so next again it has a problem at 1 also, 1 plus 1 upon x1 by 3 minus 1 upon x minus 4 by 3, right? So when x is positive and greater than 1 upon something, this will be less than 1 and positive, and when this is simply 1, and when x is greater than 1, this overall will be something, this will be less than 1, again greater than 1 upon something, so this will be 1 upon something greater than 1, so this will be minus infinity. Right, I hope it's clear what I'm saying. You just put x1, this will not have a problem, this will have 1, x1 plus, this will be something less than 1 upon x minus 1, 4 by 3 will be greater than 1, so 1 minus something greater than 1 will give you negative, so overall this will be negative, so it will be minus infinity. So your exercise is limit x tending to 1 minus 1 upon x raised to power 1 by 3 minus 1 upon same function, but okay. So that question number 18, limit x tending to 0 plus x minus 1 upon x plus 2. So it will give you infinity again when you put x tends to 0. So when x is greater than 0, this is something negative upon positive, this is positive, so overall negative, so this will be minus infinity. And limit x tends to 0 minus x minus 1 upon x plus 2, again a little greater than 0, still less than 1, so this will be negative upon negative, x less than 0, and again positive, so this will be negative, so this is again, sorry, this will be positive, so this is infinity. Okay, so these are some question on infinite limits. Now limit at infinity. Question number 19. So keep in mind that limit x tending to plus minus infinity 1 upon x m by n is 0 whenever m by n is positive. Okay, so based on this we'll do some questions, just last questions. So a part is limit x tending to infinity minus 2x cube minus 2x plus 3 upon 3x cube plus 3x square minus 5. So here the trick is that we take out the highest power from the denominator so that we get 1 upon x type of things, and 1 upon x we know that at infinity will go to 0. So taking out x cube common, so we'll have minus 2 upon x square plus 3 upon x cube upon x cube 3 plus 3 upon x minus 5 upon x square. So at infinity they will go to minus 2 by 3. Similarly at limit x tending to minus infinity, because we know plus minus infinity 1 upon x m by n will go to 2 by minus 2 by 3 only. Okay, so b part, limit x tending to infinity minus x raised to power 4 upon x raised to power 4 minus 7x cube plus 7x square plus 9. So again taking out x raised to power 4 common, so this will be minus 1 upon 1 minus 7 upon x plus 7 upon x square plus 9 upon x4. So this is minus 1. So you see that at infinity the polynomial is behaving like its leading term, the term with the highest power. Okay, like it has been discussed in class. x raised to power infinity 2x plus x minus 1 upon. So if we take out common x from the numerator and denominator, so it will be x. So this will be 2 upon x root x plus 1 upon x square, right? And from denominator, so we are taking the highest power common from both numerator and denominator, the highest power in the denominator. 3 minus 7 by x at infinity. This will go to 0 plus 0 upon 3 minus 0. This is 0. Okay. Similarly, you can do it minus infinity all these questions. Minus infinity x raised to power 1 by 3 minus x raised to power 1 by 5. X raised to power 1 by 3 minus x raised to power 1 by 5. So here we take out the highest power x raised to power 1 by 3. Sorry, it is plus. So x raised to power 1 by 3 common, 1 minus x raised to power 1 by 5 minus 1 by 3, 1 plus x raised to power 1 by 5 minus 1 by 3. So this will be limit x tending to minus infinity, limit x tending to minus infinity, 1 minus x raised to power minus 2 by 15, right? 3 minus 1 minus 2 by 15, 1 plus x raised to power minus 2 by 15. This is 1 minus 0 upon 1 plus 0 is 1. Okay, so I hope now you can do the questions involving the powers of x and you have to find the limits at infinity. One last question. Infinity 2x5 by 3 minus x1 by 3 plus 7 upon, what is it, x raised to power 8 by 5 plus 3x plus x raised to power 1 by 2. So x raised to power 8 by 5 is the highest power in the denominator. So x raised to power 8 by 5. So you will be left with 2x 5 by 3 minus 8 by 5 minus x1 by 3 minus 8 by 5 plus 7x minus 8 by 5. So here 8 by 5 common, 1 plus 3x 1 minus 8 by 5 plus x1 by 2 minus 8 by 5. So these are, when we do the calculations, 25 minus 24. So this is 1 by 15 minus x 5 minus 24. This is 5 minus 19 by 15, right? Plus 7x minus 8 by 5 and 1 plus 3x minus 3 by 5 plus x 5 minus 16 minus 11 by 10. So this is limit x tending to, I'm sorry, this is not 0, this is infinity. 2x 1 by 15 minus 1 by x 19 by 15 plus 7x 7 upon x 8 by 5 1 plus 3 upon x 3 by 5 plus 1 upon x 11 by 10. So this will be 0, 0, and this will be positive and x into infinity. So this will be infinity. 0, 0, 0, 0, 1, 2x raised to power infinity, x raised to 1 by 15, positive power at infinity will be infinity. Okay, so this is about today's class. I hope now you'll be able to solve any questions on right hand limit, left hand limit, and limits at infinity and infinite limits. So thank you. We shall meet in next class. I'll wait for 10-15 minutes here if anybody has any doubts. Okay, thank you.